Good afternoon to all. Today we are going to see about pile foundation in advanced construction techniques. First of all, before getting into the pile foundation and its technique used in advanced construction in civil engineering, let us know about what is meant by pile foundation. The pile foundation, it is used to describe a construction for the foundation of a wall or a pier which is supported on the pile. First of all, pile foundation, it is a type of foundation which is constructed deep into the ground and mostly it will be available in circular sections and are used in the construction. The shallow foundations which rest on the ground and they transfer the vertical loads directly to the soil. On such conditions, we can't use this shallow foundation which will cause us over tilting. So that we will opt for deep foundation. One such foundation is called pile foundation. And where it is adopted? It is adopted when the loose soil extended to a great depth and the load of the structure is transmitted by the piles to the hard stratum below, or it is resisted by the friction developed on the side of the piles. The application of the piles are applicable at the places where the load coming from the structure is very high and the distribution of the load on the soil is uneven. The subsoil water level is likely to rise or fall appreciably, and the pumping of the subsoil water is too costly. On that time, we can go for this pile foundation where the foundation ridge will be on dry condition. As I said earlier, see, low weight from soft to firm clay, and then a strong rock strata where the large distributed weight will be completely scattered over the entire foundation. If very large concentrated weight on these applications, we are using this pile foundation, which will not cause sliding or over tilting. And what are the loads coming on pile foundation? We have live loads, dead loads, wind load, and seismic loads. Out of this, live load and dead loads will be most common in any sort of foundations, whereas seismic load and wind load will be available only after G+3 or G+4 buildings. And seismic load is very dangerous load which may be caused due to earthquake. Okay, pile foundation can be made of different materials. Those are timber, steel, and concrete or RCC. As I mentioned, timber pile, steel pile, and concrete pile. Concrete pile may be composite, precast, or cast sensitive, whatever it is, depending on the type of the pile foundation we are using. And then types of pile. For pile foundation, we have to keep pile. Those pile are load bearing pile and non-load bearing pile. Load bearing pile, that is, it bears the load coming from the structure. The piles, which are generally driven vertically or in a vertical position, there the horizontal forces to be resisted and the inclined piles may be driven in an inclined position. And such inclined piles are termed as batter piles. Load bearing piles are driven into bearing piles and friction piles, whereas bearing piles, it penetrate to the soft soil and their bottoms rest on a hard bed. Thus, they are end bearing piles and act as column or piers. So it is nothing but two in one, which we will call as a very much great advantage. And then bearing piles, this picture you can clearly intimate in this picture that it is used to transmit most of their loads to the load bearing layer, especially in dense sand or rock. Most of the pile capacity inferred from the end bearing points, hence it is called bearing piles. Whereas friction pile, when loose soil extends to a great depth, the piles are driven up to such a depth, then the frictional resistance developed at the sides of the piles equals the load coming on the piles. Great care should be taken to determine the frictional resistance offered by the soil and suitable factor of safety should be provided in the design. See, in the previous slide where we saw bearing piles, it bears the load at the end of the pile, whereas in friction piles, it bears the load at the every side, which causes friction and it will make the pile to wrap very tightly in the foundation along with the soil. This is a major difference between the previous slide diagram and this slide picture. Okay. Timber piles, these are really inexpensive, but it is usually limited to very short length and it is of low capacity. It is easy to handle and it may not have corrosive, but a very major problem and very major and common problem in the timber or wood related materials is what it is attack of termites. So because of attack of termites, the entire timber will get disintegrated, and so that our capacity will not be satisfied. So we are not using this timber pipe. Whereas in steel pipe, what is the main disadvantage is it is costly, and it is very much difficult to very much difficult to deliver or to cast. We have to cast the entire process. If, for example, if the pipe diameter is around 30 meter, we have to cast the steel pipe for entire 30 meter. It is very much big process, and we have to do this process in the industry. So, and moreover, for every type of steel, there is a very main disadvantage. What is the corrosion? Because we, if corrosion should not be there, means we have to use epoxy coating or some corrosive resistance coating. So in that case, it will give some high maintenance and high costs. So it is also not available. So most probably what we are using is concrete piles. It is inexpensive, it is usually durable, and it is also corrosive nature. The only disadvantage is transportation difficulties, that too especially in the precast piles. So usually we will cast in situ piles. Pile spacing. The center to center distance of successive piles is known as pile spacing. For determining this pile spacing, we have to consider the following factors. Those are type of piles, material of piles, length of piles, grouping of piles, load coming on piles, obstruction during the pile driving, nature of soil through which piles are passed. For friction piles, higher spacing should be provided. Minimum spacing between piles is 2.5 and maximum spacing is 8 meter. Once again, minimum spacing is 2.5 meter and the maximum spacing is 8 meter. See, in this slide, if two, that S denotes the spacing of piles, that is center to center distance of the each pile. For 2 pile, 3 pile, 4 pile, 5 pile, and n pile, how the spacing is provided and how the piles are placed. This is the technique behind the pile spacing and placing. What are the factors that affect pile capacity is the soil surrounding the pile, insulation techniques like it can be driven or bored, method of construction like precast or cast in situ, location of pile in a group, spacing of piles in a group, symmetry of the group, shape of the pile cap, location of the pile cap, that it may be either on the above the soil or it may be below the soil, and the drainage condition in the soil. Apart from above, there are other types of pile foundation. Those are board piles that are cast in situ piles, driven piles or precast piles, micro piles, sheet piles, timber piles, and screw piles. First of all, let us see driven piles. Usually, driven piles are driven into the ground by impact force, which causes considerable stresses in the piles. The forces and accelerations induced in the pile during driving are recorded using a data logger called pile driving analyzer, which is nothing but PDA. See, in this picture, the PDA is placed in the utmost bottom of the pile, which records the data collector and how much depth it has been gone through the ground. The data obtained by PDA will be used to study the pile integrity and potentially dangerous defects like honeycombing, cracks, presence of foreign matter, etc. The PDA works on the principle of propagation. Now, we are seeing about micropiles. Micropiles are quite popular in low-rise building construction. When the ground condition is weak and there is no adequate bearing capacity to carry the loads from the superstructure, a deep foundation needs to be constructed. In this background, if look at the available options, we have to select the type of foundation from board piles, precast piles, and micropiles. Out of these, board piles are most costly in general when compared with the other two types. Depending on the nature and the type of the loads from the superstructure, the selection of piling type is made. Further, when these type of foundation are constructed, it is advisable to get the recommendation from the geotechnical engineer. But usually we are not going into it. This we are using as probably so that only most of the buildings get scattered or shattered from the foundation. The design shall be done based on those parameters provided in the soil investigation report, and those shall be verified after the construction by doing necessary tests. What I mentioned here is micropile. A micropile is nothing but a steel casing filled with concrete, which is shown in this particular figure. When required and as the diameter of the micropile is increasing, the reinforcement cage also can be placed inside the pile to improve its structural capacity. And then sheet piles. Sheet piles are the sections of sheet materials with interlocking edges which are driven into the ground to provide earth retention and excavation support. Sheet piles are most commonly made of steel but can also be formed of timber or reinforced concrete. Sheet piles are most commonly used for retaining walls, land reclamation, underground structures such as car parks, and basements in marine locations for riverbank protection. Construction method used for sheet piles are anchored sheet pile and cantilever sheet pile. And construction methods are divided into two categories. One is backfilled structure, another one is dredged structure. The sequence for the backfilled structure is initially the soil in the situ is dredged in front, and then and then backly it is proposed. Then the sheet piles are driven, and then the anchor and then anchor system is backfilled up to the level where we have to place the ground level. For a dredged structure, sheet piles are driven and then the same thing is repeated, but the backfill is filled at the top of the wall. This is the only difference. And there are other difference of sheet piles also, which we have seen already. Those are vinyl sheet pile. It is an effectively alternative steel sheet pile for bulkhead, sea walls, and cutout walls. They're also superior to alternative materials like concrete and wood. The main advantage of vinyl sheet piles is the superior corrosion resistance when exposed to sea water and no oxidation occurs. So overall, pile foundation is generally a deep foundation, which is a major advanced construction techniques which we are using very commonly, especially for the soil where the strata is very loose and where we can't or shallow foundation, so that the tilting and oversliding will be restricted and controlled. So as of today, piling technique is over. We will meet on the another tip. Thank you.